Can a tiny current from your fingertip control a much bigger current to light a lamp? Yes, and that is exactly what a transistor does when it acts as a switch. Let me show you how. Looking for the collector and emitter. Okay, so 0.717, 0.2721. So this is the emitter, this is the collector. So I have LED, which should be connected to the collector. The anode of the LED connected to the collector, and then back to the positive line. I'm going to use this very line as my positive line. You can see from the circuit diagram I have the emitter connected to the ground. So my emitter will be connected to the ground as indicated on the circuit diagram. I'm going to use we are going to use we are going to use this line as our ground. That is this very line as our ground. Okay. So this 100 kilo ohm resistor is connecting the base to the ground. So this is the base, this point, and then we shall connect this side to the ground. So, to the ground like that, and then here the LED is connected to the VCC through a 220 ohm resistor. So we need to bring the 220 ohm resistor on board. This is the 220 ohm resistor. It's on board. It's on board. There it is. It's on board. Then we can now bring our 1 kilo ohm. This is our 1 kilo ohm resistor. Put it connected to the base. So center. And then connect this tiny cable to the positive, which is this very connection here. So, and then after that we are good to connect our power line. So this is my positive line and this is my negative line. Alright. So we can now test our circuit. So when I hold this line with one arm or one hand and hold this the tip of this 1 kilo ohm resistor with another hand, there is a discharge, a tiny current from my body entering the base of the transistor. When that happens, the transistor turns on. And when the transistor is turned on, we have maximum current flowing. And this current is determined by the voltage VCC divided by the resistance here. So that gives us the maximum current, and it turns on the LED. So that is what we are seeing now. As I touch the base resistor, the LED turns on. Yeah, that's it. So we can equally replace this circuit here, the resistor in this tiny cable, with an actual switch, whereby when we press the switch, the LED will turn on. So let's try that right away. Okay, so we have the switch connected this way, and we have the 1 kilo ohm resistor from the base to one side of the switch. So this is how that is going to look like. At this point, we have this is a push button. As soon as we press this push button, initially when there is the push button is not pressed, there's a gap here, there's an open circuit, so no base current will flow. But the moment you push the push button, the contact closes and current flows from the battery to the base to drive the transistor, which allows current to flow through this resistor to turn on the LED, and then flow from collector to the emitter to ground. So let's look at that again. So we have, there you go. So that is it. Okay, so right now we want to turn on a much bigger load. This is just an LED. Typical current for an LED is about 20 milliamperes. But let us see how we can use the same circuit to turn on a much bigger load, which requires much more current than 20 milliamperes. Alright, so for the next part, we are going to take off this LED and this resistor and replace it with a relay. So let's go. We're taking off this LED and this resistor. We are going to replace it with this relay. Now, the resistance of the relay is indicated 400 ohms. So we are going to place it here. So it's going to take the place of the LED and then the resistor. But since we don't have enough space here, we are going to mount it somewhere here. Alright, mount it here, and then we need what we call a diode. This is a freewheeling diode. We just have to connect it across the terminals of the relay. That is the coil of the relay. just like that. And then we will now connect the cathode side of the relay to the positive. That's to the positive line. And then the anode side of the relay to the collector, like that. So the circuit looks like this. So we have the relay coil, that is about 400 ohms. And then we have a diode connected in parallel with it like this, with the positives, the anode side connected to the collector of the transistor. So this is the collector side, this is the emitter, and this is the base. For the base circuit, we've not changed anything. It is still the way it is over here. And this is our 100 kilo ohms resistor. Our 1 kilo ohm resistor is still here. And then our switch, as the push button, is also there. Our battery is still there, VCC 9 volts. Yeah, so that is it. So that's what we have right now. So we are going to test it and see how it works. So we want to see whether, so the operation is that when this push button is pressed, current flows from the battery to the base. The base current turns on the transistor. Now when the transistor is turned on, it's like the collector switches to the emitter. It closes contact with the emitter. So current flows from the battery to energize the relay through to the collector and then to the emitter, then to ground. Now when the relay is energized, the relay has a contact here. So we have the common contact, we have the normal close contact NO, and then we have the normal close contact NC, and then we have the NO, normally open contact. Now when the relay is not energized, the normally closed contact is already closed. So we can use it for anything we can use it for something. But right now we want to use a normally open so that we can use it anytime the coil is energized. The normally closed contact breaks and makes contact with the normally open contact, and current begins to flow through the normally open contact. So we are going to put a lamp here like this, an AC lamp, and then we'll connect one side of the lamp to neutral, and then we connect this common contact to live, that is 220 volts AC or 110 volts, depending on where you are, which country you find yourself. In Ghana, we are using 220 volts, the frequency of 50 hertz. All right, so let's try this and see. So this is our lamp. So we are going to connect one side of the lamp to the normally open contact, which is here. And then we connect the live to the other side. That is the common side of the relay. So the common is here. Connect it to it nicely. It's connected. So before we turn on the AC, we connect the AC supply. Let's test the relay and see whether the relay is functioning. Okay. So as you can see, the relay is making contact. Okay, so let's now apply power, AC power to it, and see how it goes. All right, so there you go. There you go. Okay, so the maximum DC current for this relay contact is 10 amperes. So if you are going to supply an AC load which is more than 10 amperes or somehow bigger than this, you need to get a more big switching device. Yeah. So that is it. So in this case, we've been able to use the DC circuit, which is the transistor circuit, where the transistor is acting as a switching circuit to control a much bigger current from the AC power line. Right, so that is it. So we've seen the transistor work as a simple on and off switch. But what if we let it work in between off and on? That's exactly when it stops switching and starts amplifying. And that is our next step. Thank you for watching this video.